Have you ever wondered how Netflix recommends movies? In this video, we'll be presenting movie recommendation systems. My name is Hector Gavilanes, and I'm here with Michael Carnival. Our focus will be on how the system operate and their potential to improve viewing experiences across various platforms. On the agenda, we'll cover the basics of recommendation models, including different types of recommenders, our EDA or exploratory data analysis, data pre-processing, choosing a model. We'll also discuss limitations and our solution. By the end of this video, you'll have a basic understanding of how recommender systems work. Why do we need recommenders? Recommender systems help us discover new products and services. These systems are used to analyze data patterns to generate personalized recommendations. On platforms like Amazon, they use for products to buy. Netflix and YouTube, they use it to recommend movies and videos. Spotify for music, among other use cases. Recommender systems enhances user experience by making it easier to find relevant content. Popularity based filtering recommends items based on their overall popularity or frequency of interactions across all users. Collaborative filtering, as you can see on the left graph, it is based on user behavior and similar decisions by others. Content based filtering, on the right side, analyzes the metadata of items, such as genre, keywords, actors, or directors, to identify similarities and recommend similar items to the users. It is independent of other users' preferences or behaviors. And lastly, hybrid methods. Those combine multiple approaches for better recommendation systems.
Through exploring the small movie dataset gathered by Grouplens from research group at the University of Minnesota, there are approximately 100K number of ratings, 9,742 number of unique movies, 610 number of unique users. There are an average of 165.3 number of ratings per user. There are an average of 10.35 number of ratings per movie. The distribution of movie ratings shows that most movies receive ratings of 3 or 4, with 4 being the most common. Rating of 1 and 2 are the least common, and ratings of 5 are relatively low. The overall average movie rating is 3.5, which supports that people tend to rate on the higher end. And it also suggests that movie watchers tend to rate movies moderately rather than extremely. What are the top rated movies, you might be asking? Here in the bar chart shows that Forrest Gump as the most rated movie, followed by Shawshank Redemption. In this slide, here we have America and Gypsy being the highest and lowest rated movies, respectively. However, the problem with both movies are lack of quantity of ratings for each movie. The two graphs illustrated that majority of users rate only a limited number of items, while most movies receive only a handful of ratings. This is a common issue of sparsity in user item matrix, where a small subset of users and movies um, generate the bulk of ratings.
Now we have to answer the following question: how to deal with low quantity of ratings? To address this issue, we have used a popularity based filtering calculating the Bayesian average. The following formula applies a weighted calculation, where C is the confidence or prior weight, M represents the prior mean, R represent the sum of all rating scores, N is the total number of reviews or observations. The Bayesian average accounts for the numbers of ratings that a movie has received and giving more weight to movies with more ratings. In other words, it provides a more stable estimate of movie ratings, including observed data and prior information. This helps to identify movies that are really popular. For our specific case, ratings for L'America decreased from its original rating score of 5 to 3.5 after applying Bayesian average. In contrast, towards the right, Forrest Gump remained about the same original score of 4.16. As a result, it reduced the impact of outliers and extreme ratings, leading to more reliable recommendations. After applying Bayesian average to the entire dataset, we can see in the graph the highest rated movies like The Shawshank Redemption, The Godfather, Fight Club top the list. These films make sense and it actually aligned with our expectations. The lowest rated movies like Speed 2, Cruise Control, Battlefield Earth, and Godzilla are among the lowest, and those are really bad movies. So the results showcase credibility because Bayesian average provides a weighted calculation and it helps to identify more relevant movies.
What is the pattern for movie genre? Here we have the graph displaying the top genre by count, and drama is the most frequent genre in this graph, followed by comedy around 3,500. IMAX and film noir are the least frequent genre. In the data pre-processing step, our current data matrix had movie IDs and users as column vectors. For user-based collaborative filtering to work, we need to transform our data matrix into an user item matrix, where rows represent users and columns represent movies. This is shown on the right table. Next, we have to discuss about sparsity in user item interaction matrix. When sparsity is very high, it is hard for collaborative filtering to make any meaningful recommendation. A preferred sparsity value for collaborative filtering is a value of 99 or less than 99.5%. This sparsity value ensures enough interaction between users and items for meaningful recommendation. After we have investigated the sparsity of our matrix, we need to normalize the user item matrix. The purpose of normalization helps remove systematic biases. Normalization helps to remove biases from ratings, making the data more suitable for collaborative filtering. The next is different rating scales. Users may have different rating scales, and items may receive consistently high or low rating due to unrelated factors. How can we normalize our user item matrix? Here on the bottom shows the equation to normalize our matrix. We need to calculate global mean, user bias, and item bias. Here, we implemented a KNN algorithm for our recommendation system. The K nearest neighbor is used to find movies similar to a given movie. It uses cosine similarity to identify nearest neighbor. The algorithm is simple to implement and handles sparse data pretty efficiently. By transposing our user item matrix, KNN can find similar movies based on user ratings. This approach efficiently recommends similar movie using K nearest neighbor. As you can see on the right, the results show that a person who watched Toy Story will likely to watch Toy Story 2, Bug's Life, Groundhog Day, etc. There are some limitations with collaborative filtering. The common issue with collaborative filtering is the cold start problem. The cold start problem occurs when new users or items with no prior interaction are excluded from the recommendation system. This happens because collaborative filtering relies solely on user item interaction within the user item matrix.
To address the cold start issue, we can use content-based filtering as a solution, which generates recommendations based on user item interaction matrix. This matrix involves creating profiles for each item using attributes like genre, date, actor, or any other keyword based on the metadata of items the user has shown interest in the past. It does not need to know anything about the rating scores. The system actually calculates the similarity between user and item's profile. It often uses cosine similarity to generate recommendations. We believe that a hybrid system is the best approach because we can combine all the methods available, like user based, content based filtering, to complement each other. It is like building a team with the best players in different positions. The idea is to create relevant and useful recommendations based on users' preferences. The main goal is to provide personalized recommendations. In summary, we have focused on hybrid filtering systems such as user based collaborative and content based filtering. We have constructed user item matrix, evaluated sparsity and normalized ratings, addressed the cold start limitations, used content based recommendations with movie genre features, and compute cosine similarities to identify similar movies. The main objectives are to improve user experiences across platforms, social media, e-commerce, healthcare. Engage users by providing personalized content and suggestions. Also discover valuable insights for different applications. Ensure relevant recommendations that are up to date with newer content. In conclusion, movie recommendation systems not only improve user engagement, but also enrich our entertainment experiences. by connecting us with films we're likely to enjoy. Thank you so much for your attention, and don't forget to hit the like button. Bye bye.